Good evening, everyone. My name is Tanayati. My register number is URK24AI 1077. So I'll be explaining about the experiment number 5, that is implementation of graph traverse. So our objective is to implement the traversal function DFS and BFS in the adjacency matrix representation of a graph. A graph data structure consists of finite and possibly mutable set of vertices or nodes or points. Together, we set unordered pairs of these vertices for an undirected graph or a set of ordered pairs for the directed graph. These pairs are known as edges or arcs or lines for an undirected graph as arrows or directed edges or directed arcs or directed lines for a directed graph. The adjacency matrix of a finite graph G on n vertices is the n by n matrix where a suffix ij represent whether there is an edge from vertex I to vertex j. If there is an edge, a suffix ij is 1, otherwise 0. So, yeah, so depth first search. Start at vertex A, visit neighbor B, then B's neighbor C, and keep on going until reach A dead end. And iterate back and visit nodes reachable from second list visited vertex and keep applying the same principle. So breadth first search is BFS, visits the node's neighbors and then the unvisited neighbors of the neighbors, etc. If it starts of vertex A and it will go to all vertices that have edge from A. If some points are not reachable, it will have a start another BFS from a new vertex. So this is the pseudocode for it. Pseudocode for this TFS. Use the algorithm. And let's go to the implementation. This is the implementation. So yeah, we've included studio standard input output dot edge, and we have defined maximum size that is 10, and we have declared in a given select its central matrix so given max both the limit both the size as max and another matrix called visited max q size max, and we've set front is equal to -1 and rear is equal to -1, and then int n. Then we created a function called create graph. In that we declare I and j. So we print the number of vertices and we store it in n, and we print the adjacency matrix, and we use for loop so we can access it and correct it and give and store it in the ADJ array. Then we have created another function called DFS. We've declared the variable I and visited v of size v is equal to 1. Then printf, uh, yeah, we print the v value and use for loop and check if I is equal to 0, I less than n, and I plus plus. So if the condition is true, then it again check if the adjacent of v I is equal to 1 and visited I is equal to 0, then TFS of I. Then another function called BFS, and front is equal to rear is equal to 0, q of rear is equal to start, then visited start is equal to 1. Then we print the start value using while loop. If front less than or equal to rear, then start is equal to q of front plus plus, and we use for loop. And if the condition is true, we change. If the condition, we check the condition, that is edge of start of I is equal to 1 and visited I is equal to 0. Then q plus plus rear is equal to I. Then visited I is equal to 1. Then print percentage d I. Then we create this main function and we create this create graph and enter the starting vertex for the traversal, and we store it in start. For DFS traversal, we use for loop, and we check the conditions, and according to that we give it to the DFS, and same goes for the BFS traversal also. So if we run, yeah, so we give the number of vertices as to just give to. So this is the implementation um, for the graph traversal. Therefore, yeah, therefore the program has been executed successfully. The output is verified. Thank you.